Hey guys, today I'll be going over a project that I've been working on for a couple of months now. It's essentially a personality classifier, which classifies an individual's personality based on different individual features extracted from coordinates found on the person's face or identified from machine learning algorithms. So for this project, if you guys have been tuning into my videos, you've seen that I've also done an emotion classifier. First note that emotion and personality are different. Your emotion is kind of like your current mood right now, whether you're happy, you're sad, or you're angry. While personality is kind of more your overall emotions and like how you've been feeling for the last like 16 years, however, kind of like classifies you under. So this will be things like whether you can relatively make good decisions or you're affectionate and kind. So that's kind of just a distinction between personality and emotion before we get started with this. So, like I said before, we use machine learning algorithms and the careful selection of facial features to determine the personality of a person. For this project, I mainly worked in Python using its data science libraries. I used TensorFlow and Keras along with a little bit of NumPy and Pandas. And I also use OpenCV and Dlab, and you'll see that library is extremely important as the time goes on, because that was a really instrumental part in organizing my facial features in general. Also, knowing about convolutional neural networks and object detection algorithms is extremely important in this instance, because we will be working a lot with CNNs, and you just need to have like a general overview of what it is before we go into this project, because it will get a little bit in depth and technical. So the first thing, obviously, whenever we start like a machine learning algorithm or we just try to work on an ML project, is finding the data. So the data is obviously the hardest part of the entire project. Finding the data on the internet was really hard, at least in my opinion. But I think I found a pretty good data set, the Celeb data set, which provided a data set with over 200,000 images of human faces with over 41 different facial characteristics, and these facial characteristics range from like it says over there, the arched eyebrows, the nose size, whether they're bald or not. And this is really good because we want to get as much facial characteristics as we can, so we can classify the personality the best that we can. Um, and also, it does say over there that it overlaps with some characteristics found in the Dlab library. I'll go more into that depth on that later in this video. So we also use unlabeled data. So obviously 200,000 images is a lot, but we also want to get more facial characteristics. And we found out that there was a really limited amount of data for this label data for this kind of stuff. So what I kind of proposed was to make a semi-supervised image classifier. A semi-supervised image classifier works with really small amounts of label data and a lot of unlabeled data. So it makes it really easy to train your model on just those little amounts of data and kind of just makes it easier for the data collection process and overall. So what I did was scrape images from Instagram and Twitter using the facial characteristics that I wanted to get. So for example, arched eyebrows would be hashtag arched eyebrows for the hashtag. um yeah, so I kind of just went through the code and just scraped through Instagram and got a few pictures, a lot of unlabeled pictures like that, and just a few labeled pictures. I put out a survey where I got over 100 responses, where I kind of just got a little bit of label data, like for the facial characteristics that I wanted, and I used that as my label data, and then all of the Twitter and Instagram images as unlabeled data. So as I'll skip this step for now, and I'll go back to it later. So before figuring out an individual's personality, the first step is to map the different elements of the face to determine the facial features. So of course, like we have to figure out the facial features. Unlike a human, which can kind of just like tell the facial features immediately, we have to actually code this into the computer so they can actually intuitively tell where the facial features are. So this is where we use the Dlab library, like I was talking about before. It's kind of like it works with OpenCV, and it provides a great thing for landmark detection, facial landmark detection, and stuff like that. So it provides 68 coordinates that are placed on specific regions in the face, so we can get the general proportions and use that for facial feature analysis. So if I go over here, this is kind of an example of how the Dlab library looks. So first it creates a bounding box on that face, and then it kind of just works on the general coordinates around the face. So as you can see over here, it really relatively captures the eyes, the nose, the mouth, and just the general overall structure on my face. So there's a lot of different facial characteristics that you can get from this, obviously. So over here you can see that we can get the distance from the bridge of the nose and the right side of the left of your eye to get your eye length, and even like whether you have wide set or close set eyes, which means that like the bridge of your eyes is smaller than other individuals. And also, like I show over here, although this image is a bit grainy, this is a cropped image of my eye using just these coordinates. So as you can see the applications of just using the Dlab library to figure out the coordinates, because it's really hard for computers to do this by themselves. So this Dlab library provides a really nice way to actually organize these coordinates in an efficient way. And again, I'm not only going into depth about the implementation behind this project, I'm kind of just going over a general overview. So if you guys are interested, you guys can definitely look at my GitHub repository, which I'll be linking in the description below. So, okay, so this just kind of goes over what the Dlab library actually is, which is using Haar cascades and a histogram-oriented gradients algorithm. Again, I don't have time to go over this in this video, but I'll link a few articles in the description so I can go over in more detail. So obviously these facial features are really good, and we can get all these characteristics, but it does get a bit confusing using these Dlab libraries. For example, I'll go back to this picture over here. We do miss out a bit on like the eye width and stuff like that, because the coordinates, they aren't exactly accurate, and they do miss a bit of the specificity that we really want on these algorithms, because the eye width and the eye length are really so close to one another. So this is where we use convolutional neural networks, and this is where we use our Celeb A dataset that we were talking about before. So like I said over here, some of the examples, some of the facial features that we use for the arched eyebrows, nose size, and bags under the eyes. And essentially, we made one convolutional neural network for each subsequent facial feature. And basically, what each the final output would be is essentially whether the binary classification would have the facial feature there or not. And essentially, we're training over 200,000 faces, and it would give just a yes or no question of whether the facial feature is there or not. And we definitely prioritize these CNNs over the Dlab dataset, because I just understood that like the Dlab dataset, of course it's really helpful and stuff like that, but CNNs are much more accurate in predicting data. And when I did this experiment, I got over a 97% accuracy on some of my testing models, so I definitely use this a lot throughout my implementation of the code. And just to quickly go back here, so you guys may have been wondering how I removed images that were completely useless in Instagram and Twitter. So essentially, I use the Dlab library again. So the Dlab library consists of 68 coordinates, and like I said before, that's basically how you get the bounding box around your face if you have all those 68 coordinates. So essentially, what I did, if the image did not have a face in it, then it would not produce a bounding box. So if the Dlab library did not create a bounding box or find any coordinates, then it would simply just say it was not an image and scrap it away. So that's how I got actually the relevant images that I could use for my semi-supervised image classifier, and also just to supplement my CNN in the future. Yeah, so that was a quick side note. And now that we've gotten all of these facial characteristics, we've gotten whether the facial characteristic was there or not. We use Dlab in order to figure out some of the facial characteristics that are a little more easy to spot. Now we can actually move on to classifying the individual's personality. So over here, what we used is a lookup table. So the lookup table is essentially a pandas data frame with the individual characteristic on the first column and then the subsequent strength values, depending on the personality trait on a -0, -1 to 1 scale. Now, this may sound a bit confusing at first, but I'll give you guys a really quick example. So pretend that you have a light blue color. Then essentially on the next line, you maybe have, as the column description, it'll be having a short temper, and then on the third column description it'll be affectionate. So having a light blue color will have a -1 for short temper, and affectionate may have a 0.75. So if that's the case, then on column 2, -1 for short temper, that means the person is extremely patient, because the negative essentially negates it, so it turns it the other way around. So if you have a short temper, then you'll be extremely patient instead. And essentially, if the number is closer to 1, that means that the correlation between the two is much more relevant. So in this case, he's extremely patient rather than just weakly patient or like just barely patient. Yeah, and then like I was going before, a 0.75 on affectionate it would not be extremely affectionate, but more strongly affectionate, because it's not only the strongest correlation. So after averaging all these facial characteristics, a definite personality can be identified at the ending. So when I ran through this algorithm, actually, I got that I was really good at making quick and fast decisions. However, I was a bit of a bossy person, and it said that I was affectionate and endearing, and dearly. So it did peg me wrong on a few things, but it was overall really successful. I would say it was around 80 to 85% accuracy. And going into the next sections of this project, I really want to expand my horizons and kind of like explore the different areas that I may have missed. So over here, if you look at the Dlab library, I may have missed the face, and I may have missed the hair, or I may have missed the ears. So I really want to get those as well. And over here, if you go back to the eye, this is a really grainy picture because of the glasses and the tint that it provides. So I'm gonna try to figure out some way to actually overcome this problem and actually make it easier for integration. And then along with this, I also want to expand my project elsewhere so that it doesn't just include CNNs and actually includes other Python libraries. I know there are a lot of Python libraries out there that can give more generalized coordinates, but I think the main thing that I really want to do is find more label data, collect kind of a database of information, not just a celebrity data set, but with more facial characteristics that I can kind of post on the internet or just use for my own personal extent, just to kind of like use for this project. So far I only have 100, but I really want to expand this so that my computer algorithm becomes much more accurate in the future. Yeah, so thank you for tuning into this. Let me know in the comments below if you guys have any questions. This project can all be seen on my GitHub, so please give a look on it below in the description if you guys are interested in more content. Or you guys can look at my other videos if you guys are interested in seeing maybe my emotion classifier, or how I use semi-supervised learning to actually detect melanoma tumors. Alright, thank you. So bye guys.